students, so we can get the complete that portion in this video coaching. Now we shall make the revision of the topics we have so far covered. So as I told earlier, there are 5 models. Now we shall simultaneously see how they ask questions in the exam, and also which one you have to give more important, for which unit or model you have to give more important. For that, first we shall revise the subject we studied so far. So first we shall see in model 1. So in model 1, so that title is differential equation 1. That means here we see how to solve a higher order, that means nth order linear differential equation with constant coefficient. Here in this unit, only 3 methods are given. One is how to find the solution by inverse differential operator method. Next is by undetermined coefficient method, and third one is by variation of parameter method. So in each question, so in each model there will be 2 questions, but you have to answer only one full question. So in each question there will be 3 subdivisions. How they ask question is like this. Say for example in model 1, the first question, there will be 3 subdivisions, A, B, C, like that. The first question may be from that, so like this, any question may be given like this. They ask to solve d squared y by dx squared. Solve d squared y by dx squared, or instead of this it may be, need not be square, d cube also, third order, d cube y by dx cube plus 2 into d squared y by dx squared plus dy by dx equals e power minus x plus sin x. So this may be asked for 6 marks. Okay. Next question is again from differential equation, but here the method is not mentioned. Any method you can apply, but since it's higher order, it is easy to get the solution by inverse differential operator method. Otherwise other method may be time consuming. The second question asked is here, it is solve d squared y by dx squared, d squared y by dx squared plus 2 into dy by dx plus 3y equals e power x into cos x. It's asked for 7 marks. The first one for 6 marks, and third is by undetermined coefficient method using undetermined coefficient method solve the differential equation. Solve d squared y by dx squared, d squared y by dx squared plus dy by dx minus 2y equals x plus sin x. It is one question. Another question they ask, you have to answer any one full question, either this first full question or second may be like this, solve. So this question is asked for 7 marks. Total it is for 20 marks, 7 plus 7 plus 6, 20. The second one, there may be a choice like this, solve. It is 4 d to the power 4 minus 8 d cube plus minus 7 d square plus 11 d plus 6 into y is equal to 0. It is for 6 marks. And B is solve y double dash minus 2 into y dash plus y equals x into e power x into sin x. This is for 7 marks. And C is from by variation of parameter method, by variation of parameters solve the differential equation y double dash plus y equals 1 over 1 plus sin x. This will be again for 7 marks. So question may be like this in the model. So 2 questions will be asked. You have to answer one full question, either from the first or from the second. But don't think the first one, C is always from undetermined coefficient. It may be variation of parameters. It may be variation of parameter may be asked here, by undetermined coefficient may be asked in the second one. But two questions will be asked from inverse differential operator method. One from here either undetermined coefficient method, here it may be variation of parameter, or if it is undetermined coefficient method, here it may be variation of parameters. So like that question will be asked. So you are free to select one full question. So you have to see which is convenient to you. Any method you can use, right? So if you are familiar with the undetermined coefficient method, you can try for this. If you are poor in integration, don't touch this, because in variation of parameter method, this u and v are obtained by integration. So if you don't have some practice in integration, means better to select this part, or this may be asked here in any pattern. So this is the pattern how they ask question in the exam. So when it is asked, so one question I select and show how to answer it. So for example, I select this. If you select this one, you should know how to answer this first question. Full question you have to answer, right? So for example, here you are free to select, but here is in the second one, first question, right hand side 0. So right hand side 0 means no need of finding particular integral, only complementary function you have to find. But while finding complementary function, fourth order, all the 4 roots you have to write. One root you can get by inspection, then get a cubic equation. That roots you can find using calculator also, right? So you should know how to get all the roots. So before that, once again you shall recall how to solve a differential equation. When a differential equation of this type is given, this type solution contains 2 type solution. One is called complementary function, another is called particular integral. The method of finding complementary function is same for all the problems, only changes finding the particular integral. So depending on the method, you have to change to get the particular integral. Here the method is not mentioned, means by inverse differential operator method you can find the particular integral. So for example, you take the first problem. How to answer means, here first you have to write this differential equation in terms of d operator. How to write in terms of d operator? It's dqy. First one a, it is dqy plus 2dy plus dy. So y is common, I'll write like this, dq plus 2d square plus d into y equals e power minus x plus sin x. Right. Now what is the first step you have to do? Whenever it's asked to solve a differential equation, first you have to get the auxiliary equation. Auxiliary equation means equate f of t to 0. That is, auxiliary equation is dq plus 2d square plus d is equal to 0. Here d is common, I can take outside. So get d square plus 2d plus 1 is equal to 0. So this shows either d is equal to 0 or d square plus 2d plus 1 is equal to 0. Here d is equal to 0 I got. Here it is a quadratic equation. Sum should be 2, product should be 1. It is nothing but 1 and 1. 1 plus 1 is 2, 1 into 1 is 1. So you can factorize like this, d plus 1 into d plus 1 is equal to 0. So the roots are, here d is equal to 0, here d is equal to minus 1, d plus 1 is equal to 0 means d is minus 1, here also minus 1. So it is real and distinct root, here real and equal roots. So depending on the roots, you know how to write the complementary function. So all this method you have to remember how to get the complementary function depending on the roots. Root may be real and distinct, real and equal, complex roots. In 3 cases you should know how to write it. So what is CF? CF is for the first one, C1 into e power 0x you can write. These two are repeating roots. For that, next constant write C2 plus C3x into this repeating roots. This is the complementary function. To get particular integral, there are 2 terms. We shall find it separately. One is for e power minus x, another for sin x. We shall call it as Pi1 and Pi2. So Pi1 is, because there are 2 functions, Pi1 is, what is the method? 1 by f of d. F of d first you have to write dq plus 2d square plus d of, this is Pi1 I call, for this I call Pi2. So what is this right hand side? E power minus x. And what is the method? When e power ax is there in the right hand side, the method of finding particular integral is replace d by a, provided it is not equal to 0. If you put d is equal here, what is a? A is minus 1. It is minus 1 you get. This also minus 1. So total minus 2. It is plus 2. So this becomes 0. Because minus 1 is a root here. So since it is 0, it becomes 0 at d is equal to minus 1. If it is 0, what is the method? You differentiate this with respect to d. Before that, you multiply by x. So x into 1 over derivative of d cube is 3d square plus 4d plus 1 of e power minus x. Again you put d is equal to minus 1. What happens? This is 3 here. It is minus 4. So d is equal to minus 1 you have to put. So it is minus 4. It is minus 1 square plus 1. 3 plus 1, 4 minus 4 is 0. Again becomes 0. Since it is 0, what is the method? This x becomes x square 1 over, again differentiate. Derivative of d square is 2d 6d plus 4 of e power minus x. Now you can put d is equal to a is here minus 1. So 6 into minus 1 is minus 6 plus 4 means 2 only. So we got pi1 equals, what is this? X square into e power minus x. D is minus 1. Minus 6 plus 4. So minus 2. D is equal to minus 1 you have to put. This is pi1. How to get pi2? pi2 means 1 over, this is same, d cube plus 2d square plus d of, this is sin x. If it is sin ax in the right hand side, what is the method of getting particular integral? For e power x, we replace d by a. For sin x or cos x, we replace only d square by minus of a square. Only d square is replaced by that. So to make it d square, I'll write this d cube as d square into d. Right? You can write like this. So it is 1 over d squared into d plus 2d square plus d of sin x. But what is a here? A is 1. So a square is 1 minus a square is minus 1. Method you should know. If it is sin x or cos x is there, you replace d squared only by minus of a square. Minus of a square means minus 1. So this d square is replaced by minus 1. It's minus d you get. This is d square is replaced by minus 1. So minus 1 into 2 minus 2 plus this d we get of sin x. So that minus d plus d get cancelled. It is minus sin x by 2. This is pi2. So particular integral is pi equals sum of these two. It is pi1 plus pi2. What is this? First one you got minus x squared into e power minus x by 2 minus sin x by 2. Hence solution. Solution of the differential equations y is equal to cf plus ps. So like that you can write. So if you write this much, you get full mark. So that is for the first question. Second question, it's again asked from differential equation by inverse differential operator method, because method is not mentioned. Otherwise, you can use some other method also, which you find easier. Now, how to solve this means, I'll remove this second question. Right, what is this? D squared y by dx squared plus 2 into dy by dx plus 3y equals e power x into cos x. First write in terms of d operator, that is d squared y plus 2 dy plus 3. Throughout y is common, equals e power x into cos x. First step is get the roots. Auxiliary equation is d squared plus 2d plus 3 equals 0. So what are the roots? That is d equals, if you find difficult to find sum of the numbers as 2 and product as 3, use this formula. If ad square plus bd plus c is equal to 0, how to get d? It is minus b plus or minus square root of b square minus 4ac by 2e. That is b means 2 minus 2 plus or minus square root of b square, 2 square 4 minus 4ac, 4 into 3, 12 by 2a means 2. That is 2 plus or minus 4 minus 12 minus 8 by 2, that is 2 plus or minus square root of minus 8 can written as 4 into minus 2 or minus 4 into 2 you can write divided by 2, that is 2 plus or minus square root of minus 1 is I, square root of 4 is 2, so I into 2 times root 2 whole by 2 you get. 2 is common throughout, you get, if you divide by 2, minus 1 plus or minus I into root 2. This is the roots. It is in the form alpha plus or minus I beta. If the roots are alpha plus or minus I beta, that means complex root. What is the complementary function? Complementary function is e power alpha x. Alpha means minus 1 minus x, then c1 into cos beta x, beta is root 2, plus c2 into sin beta x. This is the complementary function for this. So whatever the differential equation is given, you should know how to get it. Next, pi. How to get pi? If you use inverse differential operator method, it is 1 over d square plus 2d plus 3 of e power x into cos x. If the right hand side is e power x into a function of x is there, what is the method of finding particular integral? You have to take e power x outside. So this one take it outside. When you take it outside, this d is replaced by d plus a. A is here 1, so it is d plus 1 whole square plus 2 times d plus 1 plus 3 of cos x. So first of all, we should know what is the method of finding particular integral in different cases. If it is e power x, you replace d by a. If it is sin x or cos x, you replace d squared only by minus of a square. If it is e power ax into some other function is there, take e power x outside. After that, simplify this. It is 1 over, it is d square plus 2d plus 2, it is plus 2d plus 2 plus 3 of cos x. d square plus 2d plus 1 here, that's 2d plus 2 plus 3. Or we shall simplify this. It is d square, 2d plus 2d, 4d plus 3 plus 2 plus 1, that is 6 of cos x. Since it is cos x, the method is you have to replace only d square by minus of a square. What is a here? A is 1, so it is e power x into a square is 1, minus of a square means minus 1 you get. Minus 1 plus 4d plus 6 of cos x. So we get e power x divided by, it is 4d plus 5 of cos x. Now the method is known. After that, what to do? We need only here d square. To make it d square, take the conjugate of this and multiply the numerator and denominator by that. It is 1 over 4d plus 5 there. Conjugate is 4d minus 5 divided by 4d minus 5 of cos x. Now you know the method. It is a plus b into a minus b. So what you get? A square minus b square. A square means 4d square, that is 16d square. 5 square is 25. So 16d square minus 25. What is the method? You have to replace d square by minus of a square. D is, a is 1. So 16d square. So minus 16 minus 25. So minus 16 minus 25 means minus 41 we get. So the denominator is e power x is there divided by minus 41. This much. Then numerator 4d minus 1 into cos x. That is 4 into, it is derivative of cos x. Derivative of cos x is minus sin x. Right? Next, minus 5 into cos x. So this is the particular integral. Now what is the complete solution? CF plus PI. So solution is, you can write y is equal to CF plus PI. Like that you have to find. So this method is done in detail. So once again you are recalling this method. So that is how to solve it by inverse operator method. But third question, what is asked? Asked to solve this one by undetermined coefficient method. So here method is mentioned, so that method only you have to use. So this first I can write it as it is d square plus d minus 2 into y equals x plus sin x. First what to do? Get the roots. Auxiliary equation is d square plus d minus 2 is equal to 0. So you have to get the roots. Sum should be 1, product should be minus 2. What are numbers? We can write it as d plus 2 into d minus 1 is equal to 0, because 2 plus minus 1 is 1, this coefficient is there. 2 into minus 1 is minus 2. So the roots are d plus 2 is equal to 0 means d is minus 2, d minus 1 is equal to 0 means d is equal to 1. Or these roots you can find using calculator also. You directly write d is equal to minus 2, d is equal to 1 by using calculator. So what is the complementary function? C1, real and distinct roots. If the roots are real and distinct, what is the complementary function? That is C1 into e power the first root, that's minus 2x, plus another constant C2 into e to the power this root, that is e power x. Next you have to get particular integral. But what is the method? Method you should remember once again by using undetermined coefficient method. So first you have to assume a trial solution. But the trial solution, let Pi be, what is that? Depending on the right hand side you have to choose. First x is there. What in by x? It is a polynomial of degree 1. So first you have to assume a polynomial of degree 1, that is ax plus b. So polynomial of degree 1 means ax plus b. If it is x square, it is ax square plus bx plus c. Like that you have to continue. Plus, and for the sin x, two constants must be required. So a, b written, let it be c into cos x plus d into sin x. It may be sin x or cos x. This is same. This is the assumption. Then you have to check whether your assumption is correct or not. How to check? See whether this functions appears in its complementary function. Here sin x, cos x, here exponential function. It is not there. So your assumption is correct. So take y is equal to this one, ax plus b plus c into cos x plus d into sin x. Get all these derivatives. We need dy by dx. What is the derivative? Derivative of this much is a. Derivative of c into cos x is minus c sin x plus derivative of d into sin x is d cos x. This is the first derivative. Second derivative is again differentiate. It is 0 minus c into cos x minus d into sin x. Now substitute all these values in the given differential equation. What is given? Substituting in given equation is d squared y by dx squared plus dy by dx minus 2y equals x plus sin x. So second derivative written minus c into cos x minus d sin x. This much plus dy by dx. What is dy by dx? A minus c sin x plus d cos x minus 2y. 2 into y. Y is ax plus b plus this 2 is common, c cos x plus d sin x is equal to right hand side is x plus sin x. Now you collect all common functions together. First collect all cos x terms. How many cos x terms? Here cos x there, minus c into cos x, and here also cos x there, so minus c plus d cos x there. Any other term here is there, but minus 2 is common. Minus 2 into cos x. Sorry, here something missing. This is y, this is c cos x. So it is not C, minus 2C. Minus C, minus 2C. Total gets minus 3C. This is minus 2C, and here minus C, minus 3C. And another is D, plus D cos x. For this much terms, cos x is common, right? Next, sin x terms, right? What are the sin x terms? Here sin x is there, plus, sorry, it is, okay, minus D sin x, here minus C sin x, and another term, here minus 2D, minus 2D, minus D, minus 3D. This much into sin x. Next, which type functions? X function terms. Here only one x term, it's minus 2ax, that's all. Next, all constant terms. How many constant terms? Here a is there, here minus 2b. So a minus 2b. This much equal to x plus sin x. Now you compare this coefficient, you can get all these values. If you compare the coefficient of x, how much you get? Here x is there, here x is there. Comparing the coefficient of x, how much you get? Minus 2a is equal to 1. So a is equal to minus half you get, right? Next, you compare the constant terms. What is the constant term here? A minus 2b. Right hand side, no constant term. So it is 0. So a minus 2b is equal to 0. A minus 2b is equal to 0 means b equals, how much you get? B is equal to half into a. Because this is 0 means 2b is equal to a is equal, b is equal to a by 2. So b equals a by 2 means minus 1 by 4 you get. Right? You know how to compare all this, we've seen earlier. Next, compare the coefficient of cos x and sin x. What is the coefficient of cos x? Minus 3 plus d. Here no cos x term, so it is 0. So d is equal to 3c you get. From this we have to get d is equal to 3c. Another one, here sin x coefficient is this much. So what you get? Minus 3d minus c is equal to, here coefficient is 1. Minus 3d minus c is equal to 1. But what is, from this what you got? D is equal to 3c. So d is equal to 3c means we get minus 9d minus 9c minus c is equal to 1. So c is equal to, how much you get? Minus 1 by 10. It is minus 10 is equal to minus 10, c is equal to 1, c is equal to minus 10. So what is d there? D is equal to 3c, that is minus 3 by 10. All the constants you got. So a is minus half, b is minus 1 by 4, c is minus 1 by 10, d is equal to minus 3 by 10. So what is the particular integral? Therefore pi equals, we can write this, a means minus half x plus b minus 1 by 4 plus c is minus 1 by 10 into cos x, d minus 3 by 10 into sin x. This is the particular integral using this method. After that, write the complete solution. So what is the solution? Solution equals y is equal to complementary function plus particular integral. So you can select any one full question. Full question you have to answer, either the first one or the second one. The second one also, depending on the case, you have to use the method. So that is how they ask question in this model. Problem may be different, but pattern will be like this. So take a second model, application of Laplace transform to solve the differential equation. So from that one question will be asked. So pattern will be like this. You have to practice for this type of problems. So this is the entire thing about this engineering mathematics